Hello, and welcome to this video on Amazon's EKS custom networking. In this video, we'll take a quick look at the VPC architecture with and without custom networking, some of the challenges customers are facing, and why they choose to implement custom networking. We'll follow it up with a quick demo on how Rafay manages the lifecycle for these EKS clusters running custom networking. Let's start by taking a quick look at the VPC architecture without custom networking. Prior to custom networking, a node's primary and secondary ENIs would all reside on a private subnet defined in the primary CIDR block. If we have not planned accordingly, we can quickly exhaust all IP addresses, and this is something we typically see across customers. Re-architecting the network is quite expensive and is not always possible in most cases. So with this, custom networking was born. Let's now take a quick look at the VPC architecture with custom networking. I've added a secondary CIDR block 100.64.0.0/10. I've built a number of subnets that are served out of that secondary CIDR block. Going forward, all secondary ENIs will be served out of that subnet out of that secondary CIDR block. This will allow me to not consume IP addresses in my primary CIDR block's address space. Now that we have looked at the VPC architecture conceptually, let's take a look at a working example. In the following VPC that was created, I'm utilizing two CIDR blocks, 192.168 for the primary and 100.64 for the secondary. 6 subnets have been built out across 2 different availability zones, 4 private and 2 public. A pair of the private public subnets are utilizing IP address spaces from the primary CIDR block. 2 of the private subnets are using IP address spaces from the secondary CIDR blocks. So pods needing access to the host network will receive IP addresses from the 192.168 address space. Those pods not needing access to the host network will be assigned IP addresses from the 100.64 subnet. Now that we have built out the VPC infrastructure to run custom networking on our Kubernetes cluster, let's see how Rafay utilizes this. A spec file is a configuration of a Rafay managed cluster. It will have the full configuration of the Kubernetes cluster, including any additional add-ons or third-party support or configurations to network and VPC that might be utilized by the Kubernetes cluster. When we use custom networking, a new CRD is created called an ENI config. These ENI configs can be defined within the cluster spec. As I've shown earlier, we're utilizing 2 availability zones for our secondary subnets, US West 2A and US West 2B. In these ENI configs, we're going to define the subnets that these elastic network interfaces will be assigned to. In addition to that, if we have additional security group roles that need to be assigned to the interface, we can assign them here as well. In addition, there were 4 other subnets that we were utilizing, 2 additional private and 2 additional public that sit on the primary CIDR block. Those will be defined here as well. We will use this cluster spec file and the Rafay CLI utility rctl to create a new cluster. 30 minutes after applying the cluster's configuration file using rctl, we should see a fully functioning cluster in the Rafay console. I'm going to go ahead and look at the various pod resources to see that they are utilizing the custom networking that we have defined earlier. Upon analysis of the pods, you can see the pods are being served IP addresses from the 192.168 address space. Those pods that require this host network access will receive the addresses from this subnet. Those pods that do not require access to the host network, those will be served from the secondary ENIs and will receive addresses from the 100.64 subnets. These pods that run in the secondary subnet that need access to external resources or whose traffic needs to leave the cluster, this traffic is routed out through the instance's primary ENI and source netted to the primary IP address for that primary ENI. We can also validate using the kubectl channel. Let's take a quick look at the node's IP addresses. You can see nodes are utilizing the primary ENI, That is because those IP addresses are sitting on the 192.168 subnet. I created two deployments in the Nginx namespace, one running on the host network and one not utilizing the host network. As you can see, the pod utilizing the host network is running in the 192.168 address space, and the pod that is not utilizing the host network is running in the 100.64 address space. Well, that concludes this short video on EKS custom networking. Thanks for watching.